Leetcode 143, reorder list. It's a medium problem. It's quite standard for medium, but it might be a bit on the more difficult side, since the most efficient solution or the most efficient approach requires a bit of thinking and quite a bit of code as well. So here is the description. You are given the head. Head is the first element in a list of a single linked list. And there are multiple versions of linked lists. They're like circular, double linked list, and single linked list, and so on. And basically, the single linked list without any circular connections is the simplest form, in which you have elements which are organized in a linear fashion. So we have connections between elements, but unlike trees or even graphs, those connections are just linear, and there is nothing strange going on, and each element simply points to the next one. So there is an order, and you can even give indices to elements of a list, since the structure is linear. And in a double linked list, then you will have also, you would keep track of previous element and the next element, and here we only keep track of next element. And the list can be represented as. So here are the elements of the list, and let's say that our list has n elements, then the first one is called L0, the next one L1, and so on, up until Ln. And in this case, sorry, the list doesn't have n elements, it has n plus 1 elements, since we start from 0. And here is our task: reorder the list to be on the following form. So first we leave the first element the way it is, L0, but then we add to it Ln. So the next element after the reordering, the second element of the reordered list is the last element of the input list. And that continues. So then you have the second element from the input and the second to the last one. So n-1, and so on and so forth. You may not modify the values in the list's nodes, only nodes themselves may be changed. What does it mean? So here you have in the code example, or the real class, which is used for nodes, which store two things. First of all is value, the data or the label that node has, and second is this connection, so this arrow that points to the next element. And what we cannot do is to simply update the labels. That would be the easiest option, but we cannot do it. We have to manipulate the arrows, we have to manipulate the references. And here is an example. So let's say we have 4 elements in our list, and those elements are ordered, and even the labels are ordered in the sense that first you have 1, then 2, then 3, then 4. So what will happen after this reordering arrangement? 1 stays the same, but the next comes as the next element comes the last from the input list. So first 1, then 4, then the second element from the input, and then the third element, which is second to the last, 3. And that's basically what it means. And the second example is almost the same. You just have one more element, 5, and what will happen? First you have 1, then 5, since it's the last one, then 2, then 4, and then 3 at the end. And that's it. So let's try to draw it here and think about some solution that we may, or some algorithm that we may develop in order to solve this problem. But first we need a drawing to talk about it in more detail. So let's use this one with 5 elements. So we already have 3, 4 elements, and the 5th element comes here. And what can we do? So I would propose the following algorithm, where first we divide the list into 2 equal or almost equal, because in this case, if you have an even number of elements, then you cannot have like 2 equal parts. You would need to have one part having one more element than the other, or almost equal parts. And we will talk in a second what does it mean exactly. and second, reverse order in the second part, and third, merge both together. I'll do the balance like this. Okay? So if we divide it into two parts, like this, it's a bit thick, yeah. Maybe not like this, maybe like this, and like that. Yeah. So if we have two parts, here is our part 1, and here is part 2. Yeah. Then what we can do, we can simply, in the next iteration, reverse, maybe. Let's do it below so we don't lose track of the original list. Yeah, so in the next step, what we could do, we could reverse the connections in the second part. Yeah, and the first stays exactly the same. We break the connection between them. Yeah, and then we have two separate lists. Yeah, and we have them in such a way that the connections go now from the last to the from the last element to the middle element. And if we just start iterating from here, which would be our new head, and from here, which is our original head, yeah, then we can merge them back easily and get the final answer. So this, and that would be the result, and the result would be the following. First start with 1, then 5, then 2, then 3, and then 4. And let's see if this is what we want. No, we wanted first 4, then 3. So we need to update this. Yeah. So, sorry, I made a mistake. After 5, we have 4. So here I made a mistake. Yeah. So if we iterate from here to here in this direction after we reverse, then we would get the following. Yeah. And that's basically it. And that's how we can do it. So that was a high-level overview. Now we are zooming in and thinking about how to implement this in the code. But before we code anything, let's write down a couple things. So there is a method called slow and fast pointer, which is very popular in many linked list problems. So if you haven't heard about this, I will explain in a second, but you can also read a little bit on the subject because it's definitely good to know, which works in the following way. You have two pointers, yeah, one red, one fast, and one green, one slow. Yeah, and basically in each step, you move the fast one through two consecutive elements, and after a quick break, the fast one moves through two elements in each step or jumps through them. So if they both start in the head, and then in the first iteration, the fast one will go through two elements and will end up the element 3, and the slow one moves simply slowly or slower than this one and goes to the next element. And so it doesn't have any special qualities, it simply goes one by one. But this fast one always jumps two elements. Yeah, and what can we achieve through this? So that was the first iteration. We started here, both at the beginning. The first one moved through one element, and the second one, or the fast one, moved through two elements. So in the next iteration, this one will go here, and this one will go here. And can we continue this process? We cannot. Why? Because we have reached the end of our list. Yeah, so at this point, this last element doesn't point to anything, and we know that we have reached the last element using our fast pointer. But in the same time, we have reached exactly the middle element, or we are exactly in the middle of our list with our slow pointer. Yeah, so here's, I'll write it down. Middle. Yeah? And using this information, we can now split the list into two parts. Yeah, so the next thing is how to reverse. And to reverse connections, you need to keep track of three elements together. You need to have previous element, current element, and next element. And you get the next element by extracting the next from the current. Then you can update the current next to point in the opposite direction, went to the previous. And then you can move the previous to current and current to next. Yeah? That's basically the rule. And we can remove the background and make it like this. Yeah, and even you started here, like this, previous at the very beginning is pointing to the nub. Then current is the beginning of your list. The next is you get it from the current next. And then you do this operation. You reverse the current next to point into opposite direction, like this. But because here there is nothing, then you have to do it in the next iteration, and you move them like this, and so on and so forth, depending on how long is your list. Yeah, and in the next operation, you simply do the same thing. Yeah, up until you have no more elements. And that's one thing. And the next is how to merge. So what we will have those two parts at this point. Yeah, and we will have to at each point create temporary variable for the first part and the temporary variable for the second. Yeah, which will point. This one will be the first. Here we will start the first list. Here we will start the second. And the thing that we'll do, we will store in the temporary variable the next element first and the next element of the second. Yeah. So we will need to use two temporary variables for this, and now we will be able to update. Yeah. So first we store them, and then we update first, next. After that, we'll be pointing to second. And second next will be pointing to the original first next. And the last thing is we want to progress. So second will become sorry, here should be second next. Yeah, so second will become we should progress to second next, but because it was already updated, we use this temporary variable and the same for the first. First becomes first. Yeah. And so I have to at the same time keep track of both of them. And after we do this, so the real updates happening here. Yeah, the first will start pointing to this, and the results you can store here at the beginning. So with the first next gets updated, watch 2 seconds, and second next get updated to the original first next. This one. Yeah, and then we progress them. Yeah, so we start them here and here, but then we progress to what? To the original second next and to the original first next. Yeah, so, oh, sorry. Oh, how to stop it? So this, the first goes to this, and the second goes to the fourth. Which is not yet in the list. Now we do the same operation. So the first next will be second. So it comes here. And the second next is what was the first next pointing to, but since it's not pointing to anything, then we have to terminate and just continue from here at the last element. And that's it. Now we have to convert it to the code. We can write down all the steps. First, split the list, then reverse the second part, and third, merge. And first, we can check if head is equal to none, what will happen. And since it's an optional, it can be none. Then we have no list to traverse. We need to have at least 3 elements to do anything like this. So head next and head next. Next. And sorry is not end by or. If any of them is none, then that's enough for us to simply terminate. And here, split the list. We need slow and fast. And while fast and fast next. While so use in a second. Progress the slow by 1 element and fast by 2 elements. Yeah. And you need to have to guarantee that there is fast next. Otherwise, you would get an error here. That if this doesn't exist, then this also cannot exist. And you get an error by trying to call next on none. And that part we have already discussed here. So we can simply copy it like this. like this. And like this. Yes, and we need to also initialize current to where the slow was before and the previous to none. So, sorry, not this. And next is a keyword in Python, so you can just call it next, like this. And now we have to merge, which again we have already discussed how to do. And first, second, and then this update. Update here. And update here. Yes, and first we have to reinitialize to head, while second we need to reinitialize to ref. And second will always be either the second part will be either have the same length or will be by one element longer than the first. So we can just check for the second. What second? Should be it. The only thing that is missing is that we also need to do this thing to break the list into half. And we have to do it here. So, second will be slow next. Slow next to pointing to none. And here, instead of pointing to slow, we point to second. Okay, let's try. Do we have to return? Oh, no, we don't have to return. The type is not. So it will check here. And there is a slight mistake. Okay, let's take a look. This looks good. This part looks good. And here. This shouldn't be the case. So here I also made a mistake and haven't noticed. Sorry about that. Probably I just mentioned that it should be temp first, but wrote something else, which happens. Not have to be careful especially in such multi-step problems. So let's try again to run. It worked. So now let's try submitting, and we only beat 21%, which is not that good. But you see, after rerunning, we beat already 53%. And probably we can also get up here after some reruns. So the algorithm is ON when it comes to time complexity and O1 when it comes to space, since we don't use any additional space. Other than, of course, creating those small variables, but because they don't grow in size, like you don't create them n times more or different amount more, depending on the input, you can still consider them O1.